This podcast is on solving radical equations. A radical equation is an equation with one or more radicals. When solving radical equations, you have a couple of things that can happen. One, you can actually get an extraneous solution because when you square a negative or square a positive, you get the same answer. Sometimes the final solution won't check in the original problem. It's called extraneous or extra. You always have to check the solutions in the original equation. Secondly, you need to remember that since we are solving for real numbers, you cannot take a square root of a negative number. Therefore, we're going to have an issue with our domain. We need to determine the domain of the function, and the radicand, or part under the radical, must be greater than or equal to 0. It's always greater than or equal to 0. That means it's not negative. Our basic steps are to find the domain of the function, isolate the radical. If a problem involves more than one radical, you need to get them on opposite sides of the equation, which makes the problem trickier but solvable. You'll see this in our third example. Next, you eliminate the radical by raising both sides of the equation to the appropriate power. If it's squared, you square it. If it's cube root, you cube it, etc. Then you solve the resulting equation. You always have to check your solutions. Let's take a look at our first example. In our first example, we have x equals the square root of x plus 7 plus 5. Notice the first thing I did was I took the radicand, x plus 7, and set it greater than or equal to 0. This has already limited some of my answers. If I get a number in my solution that's under -7 or less than -7, I can't use it. Now, I'm ready to solve. When you're solving these, the first thing you want to do is you actually want to get the radical on a side by itself. So the first thing I had to do was subtract 5 on both sides. When I subtracted 5 on both sides, I ended up with the x minus 5 equal to the square root of x plus 7. I needed to eliminate the square root, so I squared both sides. Don't mess up when you square x minus 5 squared. Remember that that is actually x squared minus 10x plus 25, and on the other side you just get the x plus 7. So then when I moved everything to one side because I had a quadratic term, an x squared term, and a linear term, I ended up with x squared minus 11x plus 18 equals 0. Next step, factor both sides, or factor the left side, apply the zero product property, set each factor equal to 0, and you end up with x equals 9 or x equals 2. Our next step is to actually check. Remember, you have to check both of these solutions against the domain and against the final answer. Now, when I'm checking this against the domain, both of them work. They are both greater than -7. Now, to check this against the final solution, first, I'm going to check it when x is 9. I simply substitute 9 into the problem, do a little bit of arithmetic, and discover that yes, 9 plus 4 is 9. So 9 is a solution. X equals 9 is a good possible answer. Next, I'm going to check x equals positive 2 when I substitute it in. Notice what happens. I end up with 2 equals 3 plus 5. If I remember when I squared that x plus 7, if the number inside had been negative, it would have worked. Well, unfortunately, the square root of 9 is considered to be a positive 3, not a negative 3. 2 does not equal 8. Therefore, 2 is not a solution, and my final solution to this problem is just x equals 9. Now let's take a look at our second example. In example 2, we have an equation where it's not a square root. It has an odd exponent. Now, when you have an odd exponent, here's the first thing. You're not going to have a domain issue because you can take an odd root of a negative number. So I didn't even need to worry about the domain. All I had to do was actually solve the problem. And solving it, first I still want to isolate the radical, so I subtract 8 on both sides. I end up with negative 4 equals the cube root of x plus 2. Now, this time instead of squaring both sides to eliminate the radical, I actually have to raise both sides to the third power. When I cube negative 4, I get negative 64. When I cube a cube root, it just comes out, so I get x plus 2. Solve the resulting equation, and I end up with x equals negative 66. Again, I want to change it, or excuse me, check it. So I go to my check. I substitute in negative 66. 4 equals the cube root of negative 66 plus 2 plus 8. So 4 equals the cube root of negative 64 plus 8. The cube root of negative 64 is negative 4 because the cube root of a negative number is negative. Negative 4 plus 8 is 4. My problem did check, so x does equal negative 66. Now let's look at example 3. This is the trickiest problem of them all because we do have 2 square roots, or 2 radicals in it. First, we need to check the domain for both radicals. For the first one, I'm going to have x plus 1 has to be greater than or equal to 0. So far I know my x values have to be greater than or equal to negative 1. For the second radical, 2x minus 12 has to be greater than or equal to 0. So from this one, I will end up with x has to be greater than or equal to 6. Now, that means my solutions have to be at least greater than or equal to 6. It has to fit both parts of the equation. The only way you can do that, it's an and. It has to be greater than or equal to 6. So if I end up with a solution that's less than 6, my domain is going to throw it out. Now, before we go any farther, the first thing you want to do is make sure that the radicals are on opposite sides of the equation. Because if you're squaring them on the same side of the equation when you do the FOIL process, it's going to get really ugly and you're going to end up with radicals with different things inside. It's not pretty, different binomials. It's not pretty at all. This is why we want them on separate sides of the equation. Now when I square this on the left side, when I square the square root of x plus 1, I'm just going to get x plus 1. On the right side, when I square that, I have to remember to do the entire FOIL process. So that's the same as 1 plus the square root of 2x minus 12 times 1 plus the square root of 2x minus 12. Now, when I square that, when I do FOIL, 1 times 1 is 1. My outsides are 1 square root of 2x minus 12. My inside terms are 1 square root of 2x minus 12. When I combine the outsides and the insides, I get 2 square roots of 2x minus 12. And then my last term is just square root of 2x minus 12 squared. Well, when you square a square root, the number comes out of the square root. So my last term on this FOIL process is just going to be the radicand of the original square root, or plus 2x minus 12. I'm ready to continue on now. I've squared both sides, and notice it still looks ugly, but I at least only have 1 square root now. At this point, I'm ready to start doing some simplifying. I can see that both sides of the equation have a 1, so I don't have to worry about that. I could subtract that off both sides of the equation. I also want to get the radical by itself, so I have to get rid of the 2x minus 12, and I also am going to end up having to get rid of the coefficient of 2 as well. So let's get rid of the 2x minus 12 first. I'm going to subtract 2x on both sides, which gives me negative x. I add 12 on both sides, which gives me positive 12. On the other side, I get 2 square roots of 2x minus 12. At this point, we have a couple of options. We can go ahead and square both sides, or we can divide both sides by 2 and get a fraction and then have to square the fraction. It's equally difficult either way. I'm going to go ahead and square both sides because I don't have a major problem with squaring that coefficient first. When I square the left side, I have to FOIL that, so that's going to be x squared minus 24x plus 144. If you don't believe me, pause the podcast, FOIL it out, check it out for sure. On the next part, I have to square the 2 first, which is 4, and then I have to square the square root, which is just going to be 2x minus 12. Now I've got a little bit easier equation. I have x squared minus 24x plus 144 equals 8x minus 48. Since I have a quadratic and a linear term, x squareds and x's, I need to get one side equal to 0. So subtracting 8x and adding 48 on both sides, I get x squared minus 32x plus 192 equals 0. At this point you have options. You can factor to solve it, you can do the quadratic formula to solve it, you can graph it to solve it. Whatever technique is your happy technique, use that to solve the quadratic equation. I like to factor. I happen to know that the factors for this are x minus 24 and x minus 8 equal to 0. So I come up with two solutions, x equals 24 or x equals 8. Now I have to actually check the solutions, remember, because one or more of them could be extraneous. So I'm going to go up here, I'm going to start my checks, and first I'm going to use 24. So if x equals 24, I have the square root of 24 plus 1 equals 1 plus the square root of 2 times 24 minus 12, or the square root of 25 equals 1 plus the square root of 36. 5 equals 1 plus 6. This is not true, so I know that 24 does not work. Next, I would try it with x equals 8. Let's see what that does. The square root of 8 plus 1 equals 1 plus the square root of 2 times 8 minus 12. The square root of 9 equals 1 plus, that's going to turn out to be 16 minus 12 is 4. 3 equals 1 plus 2. This one does check, so my solution to this problem is only x equals 8. X equals 24 was extraneous, so we throw it out. This concludes the podcast on solving radical equations.